All right, this is Objective 40. We are going to work with relations and functions today. I am going to tell you, I'll try to go through this. It's really easy, but there's several different things I got to show you. So I'm going to tell you there's 19 examples that go with this set of notes. Okay, it's easy, but they will ask you, is this a function? And they will ask you with the table. They will ask you looking at the graph. They will ask you just looking at a set of points. They're going to ask you all these different ways. So that's why, it's going to take several examples to get through that, because we got to look at all the different ways that they're going to ask you this same question. Okay? So before we get going, you've got to know what a relation is and what a function is. So first of all, a relation is a set of ordered pairs. Okay? So when I'm talking about a relation, I'm just talking about a whole bunch of coordinate points put together. Okay, and there is really nothing to do here. You may want to write that on your notes. I'm just giving you an example of a relation. So you might want to just put an arrow, but this is a relation. Everybody agree that's a set of several coordinate points? Yeah. Yep. Okay. Again, there's nothing really to do on exam. I'm not asking you to do anything. I'm just showing you what an example of a relation would look like. Okay. All right, a little more vocab. Domain. When I'm talking about domain, I'm talking about the x values. And when I'm talking about range, I'm talking about the y values. Anybody want to ask me a question about range? Ms. Corns, I thought range was high minus low. Yeah, and it goes with mean, median, mode, range, right? So there are two types of range. They kind of do go together. What direction is your y values?
Up and down.
So if your range goes from, this far up and this far down, when we subtract them to see the difference between the range? And it is high minus low, but, they want you to actually subtract and find high minus low when I'm giving you a bunch of data and we're talking central tendency, mean, median, mode, range. That's high minus low. Here, when I'm giving you a function and I'm giving you points, x's and y's, then I mean the y values. Okay, so let's first, on example 2, let's state the domain and the range. So if domain is the x values, what would the domain be? 3, 5, -7, and 0. Any questions on this? This is an x, this is an x, this is an x, and this is an x. Everybody agree? Okay, so what would the range be? Everything else. So tell me what to write. 4, 6, -10, and 2. Okay? Any questions on that? How can you remember if it's x and y? How can you remember that domain is your x's and range is your y's? How do you remember x comes first? You've always heard this. X comes before y in the alphabet. Well, if domain is your x's and range is your y's, doesn't D come before R in the alphabet as well? So that's another way to remember which one's x and which one's y. Okay, so example 3, what would the domain be? -4, 7, 6. Do I need to say 7 twice? No. So if it lists it twice, you don't need to list it twice. Okay? So what would the range be? So tell me.
3 and -9.
So do I need to list all those 3's twice? No. Okay, so if they're listed twice, you don't need to. I'm just saying that basically I'm telling you that the highest point is 3, up 3 on your graph, and the lowest point is -9. So all of your y's are between those 2 points, right? Okay. Okay. I can go back. Any questions on that? Domains, x's, range y? You feeling better? Well, okay. Okay. So let's talk about a function. And you've heard this before. You've been looking at functions for several years now. For every input, there is exactly one output. In elementary school, what did they always draw for you? Yeah, and the little machine, right? You plug the X in, and out comes the Y. Well, I'm going to explain to you, if it is a function, this is what it means. It works. And right, if you have a little, and that's why they put it in a little machine, because the pieces and parts, it works. It makes it work. And so whatever you plug in for X, and it gives you what Y is, when you plug those into the equation, what happens? The two sides become equal. It works, right? This side is equal to this side. So that's, why they put it in a machine. But let me explain something to you, okay? If I give you y equals x plus 2, and I tell all of you that x is 1, okay? So x is 1. Can you figure out what y is? Yeah? What'd you get for y? If you plug 1 in to x, what did you get for y? I need to put this thing down. Huh? 3. What'd you get? 3. What'd you get? 3. What did you get? What did Grace get? Just say 3. 3. Okay. 2 plus 1 is 3. Okay. Don't worry about writing it down. Don't worry about coloring. Follow along with me. Okay? All right. So we get 3. So here's the thing is, for this particular equation, when we plug in 1, we get 3. Everybody agree? X is 1, y is 3. Would it be possible for someone in this equation to plug in 1 and get 5? Could you plug in 1 and get 3 and then turn around? If we plugged in 1 again to this equation, could I get 5? That is not possible. Every single person in this room, when you plugged in 1, you got 3. I sure hope so, right? Okay, I hope you got 3. So what it's saying is, for this particular input, how many answers are possible? How many correct answers? There's only one correct answer, and it's 3. Okay? It's not possible for you to plug in for this input, for 1, for somebody to plug in 3, or end up with 3, and somebody to end up with 5. You can't get 2 different answers. Okay? That's why it says there's only exactly one output. There's only one answer for that input, and the answer is 3. Okay? You can't get multiple answers. So, what we're going to do, the question's going to say, is this a function? Is the relation a function? Okay? And actually, I'm just going to pop these up here. I think that will work. I'll give you a second to write them down, and then we're going to talk about them. Everybody agree I've given you a bunch of relations? What's a relation? What? So a whole bunch of points. Have I given you a bunch of ordered pairs? Yes, I've given you lots of X's and Y's. All right. Let's look at the first one first and try not to look at any of the others. Okay? First of all, does everybody realize what can you do with these X's and Y's? Tell me some things you can do with them. You can plot them on a graph and they make a picture for us, right? Do you realize with that picture, what else goes with that picture? Are there equations that match the picture? You know, for every equation that we've given, like I gave you a quadratic equation, right? You put it into y equals. Did it not have a picture that matched it? When you put the equation in and you ended up with a u or an n, a parabola, did the picture not match the equation? It went with it. Yes, it did. Okay? When you graphed lines in y equals mx plus b, you had the equation, right? Y equals 3x plus 2. Is there not a graph that matches it? Everybody look at me. There is a graph that matches the equation. Okay? So what I want you to understand is, number one, with these points, there is a graph that matches it. You can plot them, have a picture. Number two, there's an equation that goes with that as well. And that equation, what would you say these points do? When you plug those points into the equation, what should happen? They should be equal, okay? I say this every day. They should be equal. The two sides should be equal when you plug those points in. So the first thing I'm going to tell you is this. We don't necessarily know the equation that goes with this, okay? Don't try to look for a pattern. Don't see, okay, what can I multiply by 1 that will give me 2? That could be the same thing if I do it to 3, I could get 4. And don't look for the pattern because you don't know what the pattern says. It might say multiply it, then add it, then divide it, then times it by half, then do this, then do that. You don't know what the equation says. Do you follow? Okay? So don't look for the pattern. Here's my question to you. Do you think, hypothetically, that you could plug in 1 and get 2? Do you think you have ever plugged in 1 into the little machine and popped out with a 2? Okay, so somewhere along the way, you've plugged in 1 and get 2. Okay. Do you think you could plug in 3 and get 4? I think so. Do you think you could plug in 4 and get 7? Somewhere. And everybody says, but I don't understand. If you're going to plug in 4 and get 7, how do you plug in 3 and get 4 and then plug in 4 and get 7? Don't look for the pattern. I'm just asking hypothetically. Okay? Do you think you've ever plugged in 4 and popped out with a 7 into that little magic box? Does everybody understand the little machine I'm talking about? Okay. Do you think you could plug in 9 and get 11? I think so. I think you can plug all of those in and get those answers. So that would be a function. Yes. Okay. Let's look at example 5. Do you think you could plug in 2 and get 3? Yes. Do you think you could plug in -6 and get -2? Maybe. Do you think you can plug in 2 and get -4? Now, wait. A minute ago, you plugged in 2 and got 3. Yes? Do you think you can plug in 2 to the same equation and get -4? That would be me like saying, all right, JT, you plug in 2. AJ, I want you to plug in 2. And they're working the same equation, right? A minute ago, we all worked the same equation, y equals x plus 2, right? And we all plugged in 1. How many correct answers were there? There's only one correct answer. For every input, there's only one correct answer. So if y'all are plugging in the same number to the same equation, what should they end up with? The same answer. Well, one of them gets 3 and one of them gets -4. What are you going to tell one of them? They're wrong. Is that possible for them to plug the same number into the same equation and get 2 different answers? That's not possible. So you can't do this. You can't plug in 2 and get 3 and then turn around and plug in 2 and get -4. This would be a no. That is not possible. Okay? What's the key here? It's not a pattern, but what's the key? X's can't repeat. Okay, repeat after me. X's can't,
X's can't.
but Y's can.
Y's can't.
X's can't,
X's can't.
but Y's can. X's can't, but Y's can. X's can't, but Y's can. All right, so the key is X's cannot repeat. You can't plug in the same X and get 2 different answers. That is not possible. A minute ago, when y'all all plugged in 1, we all got what for the answer? 3. That'd be like Wesley plugging in 1, Levi plugging in 1, one coming out with 3, and one coming out with 5. And you would look at one of them and say, one of you is wrong. Okay, that's not possible. Okay, if you're both going to plug in 1 and you're to the same equation and get 3, then you both got to end up with 3. Does that make sense? There's no way you could end up with something different. Okay, all right, so what do you think about example 6?
Yes.
Why is it a yes?
Because X's can, but Y's can.
But Y's can. It's okay for the Y to repeat, right? Can you plug in 1 and get 4? 2 and get 4? 3 and get 4? 4 and get 4? And how many don't understand how you can get the same answer every time by plugging in different things? Can someone give me an equation that could work? What could you multiply by an X and somehow end up with 4 every time? No, you can't multiply by 1. 1 times 1. 1 times 4 is 4, but 2 times 4 is not. How about 0 times X and then you add 4? What if you plugged a 1 in there? 0 times 1 plus 4. 2 times 0 plus 4. 3 times 0 plus 4. 4 times 0 plus 4. Yeah. What kind of line is that? Can someone tell me? Give you a piece of candy if you can tell me. Very good, Dylan. Flat line. Why? How do you know? Because the slope is 0. Isn't that mx plus b? Oh, yeah. Oh, yeah. Remind me, I owe you a piece of candy. Okay, I've got it in my drawer. Okay, very good. So is this one okay? Could that be a function? Yes, it's okay for the y's to repeat. X's can't, but y's can. X's can't, but y's can. All right, how about example 7? Why not?
Because -2 is X and it can't.
You can't plug in -2 and get 7 and then turn around and plug in -2 and get 5. That would be like saying, all right, Taylor, you plug in -2. Brooke, you plug in -2. They work the same equation out. What should happen? They should end up with the same answer. Well, one of them got 7 and one of them got 5. And you know what we would do if we were checking papers? I'd say, you know, how many of you do I ever, like I don't have the key with me, so what do? I compare papers to see if y'all get the same answer, right? And I'd say, oh, okay, y'all probably right because y'all both got the same answer. Well, if you get 2 different answers, I say something went wrong, okay? That just doesn't happen. So this one is not a function. Okay, does everybody understand that? Okay, so that's one way for them to ask you, just to give you a set of points, okay, a relation. Here is another way for them to ask you, and this is called a mapping. It's still a set of points. It's just written with a little map here, okay? This says when x is 2, what is y? What's it pointing to? 9. That's your y. Okay, when x is 4, what's your range? 5. When X is 11. What's the range? 5. It's pointing to 5 as well. Could that be a function?
Yeah.
Can you plug in 2 and get 9? Can you plug in 4 and get 5? Can you plug in 11 and get 5?
Yeah.
You sure you can get the same thing? Y's can repeat. X's can't. So this one could be a yes. Okay. I'll give you a second to write these down, and then we'll talk about the rest. Okay. Why don't you take a minute and see if you can figure out, are they functions or not? The good news is we're already to example 11, and we only have 8 more to do. It is a C. Dylan, you like Twix? I met your mom this weekend. I told her it was no excuse that you go and ride bulls instead of coming to the baseball game. It's pointing to the 4. Yeah, I agree. Okay. How about example 9? Is it a function?
Yeah.
Can you plug in 2 and get 9?
Yeah.
Can you plug in 4 and get 5?
Yeah.
Can you plug 11 and get 6? Yes, each input is going to its own output. So this one would be a yes. Okay. How about example 10? I know it's using A, B, and C, but what are variables? They stand for what? Numbers. So it's still the same thing. Can you plug in A and get 3?
Yeah.
Can you plug in B and get 1? Can you plug in C and get 2? Is it a function? Yeah, yeah. Okay. How about example 11? Nuh-uh, why not?
Because the 0 is pointing at 2 and 3.
You can't plug in 0 and get 2 and then turn around and plug in 0 and get 3. That would be like Kathleen plugging in 0 and Grace plugging in 0. One of them gets 2, one of them gets 3, and then Parker looks at their answers to check them, and they're not the same. So Parker says, one of you is wrong. Which one's right, Parker? That one is not a function. That's not possible. We know that's not possible. It doesn't work. Okay, it doesn't work like that. You can't plug in. Remember when we were doing elimination and substitution? Didn't we solve for one variable and then plug in to find the other? Well, when you solved and you plugged in, we all came out with the same answer. It's not possible. If somebody came out with 2 different answers, somebody got the points wrong. Okay, that's not possible. Sometimes they just throw extra numbers in. Okay? All right. We're getting close. Now what they're going to do is give it to you in the form of a table. It's the same thing. Okay? So you know what they're going to do on the SOL is they'll probably give you one in form of a relation, just a whole bunch of points in a set. They'll give you one as a mapping. They'll give you one as a table. They'll even give you one as a graph. And I'm going to remind me at the end of this, I'm going to have to go and draw some graphs for you. Why do they give it to you in all these different ways? So, multiple ways to do it. And again, we've talked about this. If you want to be good at something, you need to know multiple ways to get the job done, and they want to make sure you realize it's all the same thing. Okay? What is different about this? It says f times x. That is f at x. And I want you to understand that f at x is the same thing as y. Okay? It's just saying the function, the output that you get when you plug x in. Does that make sense? F at x is the output you get, the function at x, when you plug x in. Okay? F at x. All right, is example 12 a function? Can you plug in 1 and get 2? 2 and get 4? 3 and get 6? 4 and get 8? I sure hope you know how to read these tables, because we have been reading these tables in our calculator, right? You know, when you see x is 1, y is 2, that means when you plug in 1, you get 2. Okay, that one's good. How about example 13? Nope, why? You can't plug in -2 and get 4, and then plug in -2 and get -8. That is not possible. Okay? Example 14. That one okay? But the -4's repeat.
That's a wow.
Y's can. It's okay that they repeat. That's fine. Okay? That one's a yes. And example 15.
No.
Why not?
7.
Because the 7's repeat. And why can't the 7's repeat? Because x's can't. X's can't, but y's can. Okay? I love it. In about 2 weeks from now, when I ask you this question, you'll be like, Ms. Corns, x's can't, but y's can. Promise you'll remember it. Any questions on those? Okay. I'll give you a second. I'm going to go away from this for just a second, and I'm going to finish up examples 16, 17, 18, and 19, and then I need to draw some graphs on the board, which are really easy to look at, but I'll do that at the very, very end, and we'll look and see if they are functions graphically. Okay? Everybody good? Okay. Example 16. What we're going to do now is I'm going to ask you to evaluate some of these functions. So the question is they want you to find f at 2 and f at -3 when y equals 3x plus 2. Okay? There's a couple ways you can do this. The first way is, if this is f at 2, these functions are at f at x. So what are they asking you to do? To plug 2 in for x and find, if it's f at 2 is the output you get when you plug 2 in for x. Does that make sense? So f at x, and that's why. So what we're going to do first is we're going to plug 2 in. Can you plug 2 and -3 in the same problem? No, you're going to have to do 2 separate problems. One you have to plug 2 in, and one you'll have to plug -3 in. So 3 times 2 plus 2. You're just going to plug it in. Okay, and y'all did this in elementary school, right? Okay, you plugged in, except they probably said x is 2. What is y? Now they're going to say find f at 2. It's still the same thing. Okay, so 3 times 2 plus 2, y is 8. Okay, so f at 2, when you plug 2 in for x, that is equal to 8. Okay, either or. You'll see both. Okay, and then you do it all over again. This time you're going to plug in -3. And so that gives you -9 plus 2. So y equals negative 7. So f at negative 3, when you plug negative 3 in for x, the output you get is negative 7. Okay? You tell me this. How can you put this in your calculator? So tell me what to start with. Go to y equals, do this with me. Everybody get your calculators out. Go to y equals, what are we going to put in y equals? All right, so let's put in 3x plus 2. Then what? Give you a piece of candy if you can tell me. Go second table. And then what, Bennett? Go to where x is 2. What does it say y is? 8. Woohoo! And then what do we do? Go where x is negative 3. And what does it say y is? When you plug in negative 3, you get negative 7. Does that make sense? You can just look at your table. Remind me, are you a piece of candy? I know a bunch of them said it, but you said it the loudest, so. Dylan said it too, and so did Tommy. All right, here we go. So, take a minute. Can you work this out? Now, what's the question that everybody says when you work this out? We're going to do it by hand, and then we're going to do it in the calculator. Okay, what's the question that everybody says? How many x's are there? 2. There's an x squared, and there's an x. So, do you put 1 in for one of them and negative 5 in for the other? No. You put 1 in for this one, and you put 1 in for that one. Solve it. Okay, what can you put instead of y, or instead of f at x? You can put y equals, so we will put 1 in first. Solve it out. And then we are going to put in negative 5. All right, I did this on purpose. I'm going to let you, I wanted you to attempt it first. How many, everybody got through the first one? Yes. Because this is the #1 missed problem on relations and functions. A problem like this that's quadratic. How many got 6 when you plugged it in? Yeah. I got 1, 2. Nobody else got 6? When you plug it in for 1. You got 6? How many got 6? Oh, more hands in the air. I'm talking about the first one. How many got 6? Woo! How many got 0? So,
I got 0.
all right. Can I tell you what happened? Number one mistake, and I wanted you to do this on here so that you don't do it on your worksheet. Okay? 6 is not right. 0 is right. Okay? Do you know how they got 6 though? How many people multiplied this first, 3 times 1, and then squared 3 and got 9? And then you did 9 minus 4, which is 5, plus 1, which is 6. Yeah, why is that not right, Parker?
Because you got
Please excuse my dear Aunt Sally. Exponents come before multiplication. You don't want to multiply that first. You want to square this first, okay? And I guarantee you, I had 4 people raise their hand that got 6. I guarantee I had more than that. I guarantee you, I probably had about 10 of you, okay? You had, okay? All right, here we go. 1 squared, use your order of operations, is 1. Minus 4 times 1 plus 1. Then we multiply. We can multiply that, and we can multiply that. They're on the same line, but they are separate from each other. Okay, 3 times 1? Negative 4 times 1? And then from left to right, we subtract first and get negative 1 plus 1, which is 0. Gotcha. Okay? Does that make sense, though? Order of operations. And that's just a simple rule. You always have to go back to that. You cannot forget that. And when you put it in your calculators, guys, everybody do this with me so you'll know where it is. If you don't practice putting it in, you're not going to know where it is. Put in 3x squared minus 4x plus 1. And then you go where? Second table. And we look in, what are we looking for? X is 1. What is y? Y is 0. Okay, does that make sense? And you can check it. So same thing here too. When you plug this in, okay, negative 5 squared, you got to square first. What's negative 5 times negative 5? Positive 25 minus 4 times negative 5 plus 1. We can multiply that. We can multiply that. 3 times 25 is 75. What's negative 4 times negative 5? Positive 20. So that gives you 96. And if you look, let's go look at negative 5. If you go to where x is negative 5, y is 96. Okay, so you can work it by hand, but I caution you, PEMDAS. You still got to follow that. You thought, you were done with that in elementary school. You're not done with that ever. You have to follow PEMDAS. Okay? All right? 2 more and then the graphs. We're almost done. 2 more and then the graphs. We're almost done. This one says, find the range y equals, find the range for y equals negative 2x minus 1 for the given domain. What does that mean, given domain? They're giving us the x's. So what's negative 2? Negative 2 is a x, 3 is a x, and 5 is a x. And if they're asking you for the range, they want to know the, that's mean, mean, and mode. They want to know the y values. Okay, so for when I'm giving you x's and y's, so A, what could we do? You will have 3 answers. Because when you, what are we going to do with negative 2, 3, and 5? You're going to plug each one of them in one at a time. So, negative 2x minus 1, we're going to first plug in negative 2. And what do we get? We get y is 3. Okay? Then you turn around this time, we're going to plug in 3. And we get negative 6 minus 1, so y is negative. Then we're going to plug in 5. And so negative 10 minus 1, so y is negative 11. Okay, I would like for you to work them by hand, but what's a great way to check yourself? Go to y equals, put in negative 2x minus 1, and then when you go to the graph, when x is negative 2, what's y? 3. And then when x is 3, y is negative 7. And then when x is negative 11, or excuse me, when x is 5, y is negative 11. And you can look right in your table. Okay, find the matching point. Don't you wish you had this last year when you had to plug all those things in? Wouldn't that be nice? Okay, any questions on that? We're getting close. Okay. I think it's good for you to do this and practice doing this and putting it in and working it by hand, because that will remind you of your order of operations. Does that make sense? And that will be good practice for you. And then it's good to, I'd like for you to check in your calculator. So when we do our work today, I want to see work where you plug it in. I want to see that you can work your order of operations out, just as a reminder, because what happens on the SOL if I just let you plug it all in the calculator? Then on the SOL, what's going to happen? Well, you're going to mess up on you've got your calculator you can use, but there might be other types of problems where you have to use your order of operations. You follow? Yes? So I'd like for you to make sure you practice your order of operations. Okay? Yep. In a minute. All right. We're almost done. So again, we're looking for the range for the given domain. If this is domain, then these are what? These are x's, because that's what domain is. And we are looking for the y's. So please take a minute and plug each one of those in. How many problems will you have? 3. Make sure when you square a negative that you put it in parentheses in your calculator. And can you put that whole thing in your calculator? Like, can you put in 4 parentheses, negative 1, close parentheses, square, plus 2, parentheses, negative 1, close parentheses, minus 1, enter? Like, you could put the whole thing, working it out by hand, in your calculator. All right, if you check out up here, I have plugged in each of them, and I came out with 1, negative 1, and 5. Okay, Anybody have questions on how I plugged it in? Yes. No, the first thing I did was I squared -1. Follow with me. -1 times -1 is 1. So I put a 1 in. Then I multiplied. 4 times 1 is 4. 2 times -1 is -2. And then I subtracted. 4 minus 2 is 2. And 2 minus 1 is 1. No, I just multiply and multiply. Okay. Over here, why did I cross out through all these? Because they basically go poof. Okay, 0 squared is 0. 4 times 0 is 0. And 2 times 0 is 0. And 0 minus 1 is -1. It all goes basically poof, leaving you with just -1. Okay? And over here, 1 squared is 1. 4 times 1 is 4. 2 times 1 is 2. And 4 plus 2 minus 1 is 5. And then, again, this would be, Dylan asked you a little while ago, how would you like us to write it? You know, if they give you the domain like so, then this is probably a great way to write your answers. The range is that. What if you get the same answer twice? Do you have to list it twice? No. So you could have 3 problems, and then your range comes out to equal 5 and 1 if you get like 1 twice. Okay? All right. Last thing I need to show you, and I need to go and draw. Okay, so the question is this a function? Is this a function? And they're looking at it graphically. Okay, we are going to use something called the vertical pencil test. Okay, anybody ever heard of the vertical pencil test? Okay, what you're going to do is hold your pencils vertically. What direction is that? This way, vertically. Okay, and you're going to put it on your graph. Okay. How many times does my ruler or my pencil cross the red line? Once. If it crosses once, it is a function. This is yes. Can someone tell me what kind of function that is? It is a parabola. Okay. What is it? Quadratic. X squared. Okay. Using ends. Okay. We know that is a function. How about the second one? How many times does it cross the red line? Once. Is it a function? Yes. What kind of function is it? It's linear, because what shape is it? A line. Okay. That's mx plus b right there. Okay. It's a line. Okay. How many times does it cross the red line here? Twice. That is not a function. And I'm going to tell you why. Somebody estimate this point for me. Left, -1, 3. Sure. And then estimate this point, because that's where it hits, right? Twice. That point would be -1, -3. Can you tell me why it's not a function? Because the x's are repeating. That would be like Angel plugging in -1 and Christina plugging in -1. One gets +3 and one gets -3. One of them is wrong. That ain't right. Okay, that can't happen. So this is a no. How about this one?
No.
No, twice. How about this one?
Yes.
Is that one okay?
Yes.
Yes, and I'll tell you, you will learn this in Algebra 2. That is actually a 4th degree. Okay, so far in Algebra 1, you've learned degrees of 1, linear, and you've learned degrees of 2, x squareds, quadratic. Okay, that one is actually x to the 4th. Okay, how about this one?
No.
No. How about this one? How many times is it hitting? A bunch. Okay, it's hitting a bunch. And it can have, if you look at those points, estimate. This would be -5 up 2. This would be -5 0. This would be -5, -1. Okay, that would be like Levi plugging in -5, Jimmy plugging in -5, Bradley plugging in -5. One of them gets 2 for X, or for Y. One of them gets 0, and one of them gets -1. We need to review this problem because obviously we ain't getting the right answers. Does that make sense? That can't happen. That is a no. Okay? Can someone tell me why it's a no? What kind of line is it? It's an undefined line. It's not possible. Does that make sense? It's not a function. Okay? All right. How about this one?
Yes.
Yes. That one is a yes. That one's okay. Okay? All right. These, where they give you just points, I would say if you drag your pencil vertically across and you hit any 2 points at one time, it's a no. So there's a point there. That one's okay. Nope, nope, nope. That ain't okay. That one's a no. Okay, because your X's are repeating right there. Okay. How about this one?
It's okay.
That one's okay. If you drag it across, this is okay, that's okay, that's okay, that's okay, you're fine. Okay? How about this one? Yes, and again, this one is one you'll learn in Algebra 2. It's a cubic, x cubed. Okay? So you got x to the first power, linear, x to the second power, quadratic. When you get to Algebra 2, you'll learn x to the third power, and then x to the fourth power. You'll learn all kinds of functions. That one's a yes. Will you learn anything about circles? Yep. You sure will. Okay, but it's a no. It's not a function. Okay? Any questions on that?